All around us, there's this invisible tech that's quietly making our lives easier, safer, and way more efficient. Today, we're going to pull back the curtain on one of the cleverest examples out there, the humble but brilliant rain sensor. I mean, really think about it for a second. You're driving, a few drops hit the windshield, and before you can even think about it, your wipers just spring to life. Is it magic? Well, not exactly, but it's just as cool. So, right now, we're going to uncover the secret behind this everyday magic. We're going to look at the simple little device that powers so many of the automated systems we totally take for granted. Let's dive in. At its heart, a rain sensor is pretty much exactly what it sounds like. It's kind of like a specialized detective, and its only job is to spot rain. Then, once it sees it, it tells another system what to do next. Whether that's turn on the wipers or, hey, shut off the sprinklers. Okay, but how does this thing actually see the rain? The secret isn't some tiny camera or a microphone. Nope. It's a wonderfully simple principle of electricity. The best way to think about it is like a light switch that gets flipped by water itself. All right, this slide breaks down the whole elegant process. So first, look at step 1. When that sensing pad is totally dry, you've got these exposed conductive lines. Think of them like two sides of a canyon. Electricity just can't jump that gap, so the electrical resistance is super, super high. Then, a raindrop lands. Now here's the cool bit of science. Pure water is actually a terrible conductor, but rainwater is full of stuff, dust, minerals, you name it, and that lets it conduct electricity. So that one little drop forms a bridge, connecting those two lines. And finally, with that water bridge in place, bam, you've got a path for electricity. The resistance just plummets, and that sudden drop is the signal. It's the sensor basically shouting, hey, it's raining over here. So we get the principle, but how does that translate into actual hardware? It really all comes down to two key parts working together. First up, you have this sensing pad. This is the eyes of the operation. It's that circuit board you see right there with those conductive lines just sitting out in the open, waiting for rain. It's usually nickel-plated so it doesn't rust. Then you've got the control module. This is the brain. It's an integrated circuit, usually with something called a comparator inside, that is constantly measuring the resistance on the pad. The second it sees that big drop in resistance, it makes the call to send out a signal. So the brain has made a decision. But how does it communicate that decision? Well, the sensor can actually speak two different languages, and which one it uses really just depends on what the other system needs to know. Let's break this down because it's pretty neat. On one side, you have the digital output. This is like your standard light switch. It's either on or off. It answers one simple question. Is it raining? Yes or no. It sends a simple high or low signal, and that's it. But the analog output, now that's more like a dimmer switch. It gives a variable signal that actually changes depending on how much water is on the pad. A little bit of water, you get a low voltage. A ton of water, you get a high voltage. This is perfect for when a system needs to know how much it's raining, not just if it's raining. Okay, so we have this simple, really tough little device that can detect rain and report on it in two totally different ways. So where do we actually see it making a difference? Well, the applications are all around us, building a smarter and, a drier world. Let's start with the one we're all familiar with, our cars. That automatic wiper function, it relies on an analog rain sensor, so it can adjust the wiper speed based on how hard it's raining. It's a huge boost for safety and convenience. They're also massive conservation tools. Smart irrigation systems use a simple digital rain sensor to just pause their watering schedules when it's pouring outside. It saves water, it saves money, and it keeps you from drowning your lawn. This tech also protects our homes and buildings. Modern smart homes use rain sensors to automatically close up windows, skylights, and pull back awnings. It prevents water damage before it even has a chance to start. And on a much bigger scale, scientific weather stations use really sophisticated rain sensors to collect the critical rainfall data that feeds all our weather models. This is absolutely vital info for everything from farming to predicting floods. So from our daily commute and our gardens to the buildings we live in, and even in super controlled environments like greenhouses, this one simple principle is just hard at work making our world that much more responsive. When you boil it all down, it's not magic. It's just really elegant physics. A simple, totally reliable change in electrical resistance. That's the key that unlocks this huge range of automation, making our world safer, more efficient, and just that little bit smarter. It really makes you think, doesn't it? If such a basic principle can be used in so many ways today, what comes next? What would a world look like if every single surface, from the clothes we wear to the roads we drive on, could actually sense its environment? What kind of problems could we solve then?